At the heart of the solar system burns a star that has sustained every known form of life. A sphere of fire so bright that we cannot gaze upon it without risking our sight. Its name is the Sunday, a colossal mass of plasma that has burned for more than 4.5 billion years, fueling every dawn, every ocean, and every breath on Earth. But the Sun is more than a source of light. It is a cosmic engine of energy, a natural nuclear reactor that holds the entire solar system together. Its gravity governs the dance of planets, comets, and asteroids. Its solar wind shapes the magnetic fields of interplanetary space, and its heat defines which worlds can cradle life and which remain frozen in eternal darkness. Deep within its core, the Sun fuses hydrogen into helium, releasing an inconceivable amount of energy. Every second, it transforms more than 600 million tons of hydrogen. A fraction of that energy travels for hundreds of thousands of years through its inner layers, and when it finally escapes the surface, it crosses the vacuum of space in just 8 minutes. To illuminate our world, and yet, despite its proximity and vital importance, we still know so little about it. The Sun is, at once, our nearest neighbor and one of the greatest mysteries of the universe. Why is its outer atmosphere, the solar corona, hundreds of times hotter than its surface? How can its magnetic fields intertwine and snap, erupting into violent bursts of plasma known as solar flares? And what secrets lie hidden within its depths, where matter behaves in ways even our most advanced equations cannot fully describe? Each decade, astronomers uncover something new that challenges our understanding. In 2021, NASA's Parker Solar Probe became the first human-made object to touch the Sunday. It passed through the Sun's outer atmosphere, collecting data on the solar wind and magnetic fields. What it found astonished even the most seasoned scientists. An environment far more dynamic and turbulent than anyone imagined. Streams of energy moving at unimaginable speeds and temperatures that defy logic. Despite its apparent stability, the Sun is a beast in constant change. Every 11 years, its magnetic activity resets in a cycle that transforms its surface. Sunspots multiply, eruptions intensify, and radiation surges. These cycles affect Earth more than we realize, disrupting satellites, distorting communications, creating breathtaking auroras, and, in extreme cases, even threatening to collapse entire power grids. But its power is also what makes life possible. Without its energy, Earth would be a frozen rock at 270 degrees Celsius. Plants could not perform photosynthesis. The climate would halt. Water would become a motionless memory. The Sun is the beating heart of our world, and everything we know depends on its constant rhythm. And yet, it will not last forever. In about 5 billion years, the Sun will exhaust its hydrogen fuel and begin to change. Its core will collapse, while its outer layers expand, transforming it into a red giant, large enough to engulf Mercury and Venus, and perhaps even graze Earth's orbit. Life, as we know it, will vanish. But even in its death, the Sun will seed the cosmos with heavier elements: carbon, oxygen, iron. The same ingredients from which new stars, new planets, and perhaps new forms of life will one day be born. Such is the paradox of the Sun, both destroyer and creator, chaotic and precise, mortal and eternal at once. An ordinary star, yet utterly indispensable. Without it, the solar system could not exist. Because of it, life blooms in a corner of the universe that would otherwise be empty. Many ancient civilizations worshipped it as a god. Today, we study it as scientists. But deep down, the sense of awe remains the same. We still orbit its mystery, striving to understand how a ball of fire suspended in the void could become the origin of everything we love. The Sun does more than give us light. It reminds us that we are children of the stars, fragments of cosmic dust that once awakened beneath its radiance. And as long as it continues to shine, it will go on telling its story. A story written in fire, energy, and time. The Sun, that radiant sphere that seems eternal, stable, perfect. But beneath its surface lies an unending chaos. An ocean of fire where plasma boils, magnetic fields twist, and energy erupts with a force powerful enough to alter the fate of entire planets. For centuries, we believed we understood the Sunday, that it was a constant sphere of flame, a predictable beacon in the sky. But modern science has revealed a more unsettling truth. The sun is not stable. It is a perpetual storm, a living reactor that breathes, pulses, and changes. Every second, on its surface, plasma rises in colossal columns, thousands of kilometers high, propelled by immense magnetic fields. These pillars swirl, collide, and sometimes entangle until they snap. And when they do, the energy released is so vast, it could destroy Earth if we were in its path. These are solar flares, eruptions of extreme radiation that burst outward at the speed of light. When one of them reaches our planet, Earth's magnetic field trembles. Satellites shudder. Power grids fail, and the sky ignites with auroras dancing across latitudes, where they were never meant to appear. And yet, those same solar storms are among the most beautiful spectacles in the universe. Matter from the sun, traveling millions of kilometers, just to paint the heavens of our world with shimmering light. But there are deeper mysteries still, phenomena that even our most advanced instruments have not yet been able to fully explain. One of them is the solar corona, that bright, ghostly atmosphere that surrounds the star. According to physical logic, it should be cooler than the surface. But it isn't. The corona reaches temperatures of over 1,000,000 degrees, hundreds of times hotter than the sun's visible layer. The photosphere. How can something so far from the core be hotter than the surface itself? No one knows for certain. Some scientists believe magnetic fields, breaking and reconnecting, release invisible bursts of energy, tiny micro-explosions that heat the corona from within. Others suggest sound and magnetic waves, imperceptible to our senses, travel through the plasma and deposit energy in the upper layers. Whatever the answer may be, the paradox remains, and with it, the feeling that we still do not truly comprehend. The nature of our own star. Across the sun's surface appear dark spots, regions of lower temperature where magnetic fields rise with immense strength. They are the anchors of solar magnetism. Each one can be the size of Earth, or larger. When several of these regions connect, they form gigantic magnetic arcs that hurl into space. Thousands of tons of superheated plasma. These eruptions are called coronal mass ejections. When one of them is aimed at Earth, the space between the sun and our planet becomes an invisible battlefield. The solar wind crashes against Earth's magnetosphere, distorting it, triggering geomagnetic storms that can disrupt compasses, communications, and even endanger astronauts in orbit. In 1859, such an event changed history. It was the Carrington event, the most powerful ever recorded. Auroras were seen as far south as Cuba and Colombia. Telegraph wires caught fire. And if something like that happened today, in our digital, satellite-dependent age, it could collapse entire power grids, disable GPS, and disrupt global communications in a matter of minutes. The sun, the same star that gives us life, can also remind us just how fragile our civilization truly is. A single eruption on its surface could be enough to push us centuries backward. But there is more. In recent years, astronomers have detected coronal holes, dark regions where the solar wind escapes at unimaginable speeds. They are like open windows to deep space, and each time they form, the torrent of charged particles they unleash travels all the way to us. Sometimes, these holes appear in regular patterns, as if the sun itself had a pulse, a magnetic breath, marking its own rhythm. Some researchers believe these structures may reveal the existence of hidden internal currents, zones within the sun that rotate at different speeds, creating a pattern of energy we still don't understand. Others suggest that coronal holes may be the key to explaining how the sun ejects mass and energy into the cosmos, seeding the interstellar medium with the very elements that give birth to new stars and new worlds. In other words, the sun doesn't just give life to Earth, it gives life to the universe. Every atom of carbon in our bodies, every molecule in the leaves of trees, comes from stars that once burned as brightly as this one.